Good evening and welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or one of the 50% of the people watching that have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join the show and express your views on the shape of the Earth, simply click on the link in the info box below this video, but be sure to mute the page you are currently watching before you do so. In a moment, I'm going to transition across to my photographs so I can share the show on Facebook, Skype and Twitter. And I would encourage anybody who is in the live stream now to please also do the same. Please share the show on Facebook, Skype and Twitter. Once more, if you are new to this channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. We have been joined by Arwin. Very pleased to have you here, Arwin. How are you doing?
Oh, feedback loop.
Good to see you.
Yeah, sorry, I forgot to mute.
No, it's all good. Need
There
to
you
level you
go.
up anyway.
Yeah, hey Nathan. Yeah, I just checked your channel and like the second I checked it, you started the hangout, so
Perfect
it's
timing.
funny. Yeah.
Excellent. Well, the mic's all yours, Arwin.
Okay. The Earth is flat, the Earth is flat. No globers can touch the flatness. Imaginary curve. Yeah. Well, I pretty much said everything there is to say about it, so love to explain stuff. Here come the people. See some people showing up in chat. Anyway, yeah, like to reflect back for a short moment here about the whole Riley situation earlier, which I thought was kind of hilarious. They got a bit naughty, I think. But yeah, I did actually talk to him over Skype right before that video of his for a pretty long period, like face to face with camera and everything, and I explained to him exactly what he was looking at, every detail of it, explaining exactly how it works, what causes it, everything. And then he made the video, I responded to him, and he just said, yeah, I heard it, and I just disagree. But he refuses to really yeah, he just says, I disagree, but he doesn't have any alternative for it. So he just leaves it open, and I thought it was kind of insulting. So that's that. Anyway, yeah, there's no curvature. There's only apparent curvature, optical effects, perspective after a certain distance, depending on your perspective limit or whatever you're looking with. What you get to see changes, and depending on the atmospheric conditions, you get mirage type effects that cause parts of what you see to be erased and become a reflection of what is actually above that. And it's very weird. It's pure optics. That's what that is. But it's very flat when you measure it out. And if he really wanted to know in person exactly what that was, then he'd have to go to that location, same type of conditions, weather conditions, get a boat, and actually film it and go there, move towards it, and he'll see. You'll see how the image changes, how the mirage migrates, and the objects become more as they actually look. That's what I would predict. But yeah, somebody would actually have to go there with a boat and a camera. So I'm done.
Oh, save me typing if you've run out of steam. I'll do a few shout outs
Out
to
of
people in
steam.
chat.
No, just explain that thing, and that was that. That's about the optical curve mirages, and I say that mirages like that are caused by heat exchange of a solid surface like a road in the desert. It will start to, yeah, it's even closer up when it's hot in the desert, and you will see a clear mirage being a reflection of what is directly above there, and in the right conditions on sea, well, the ocean will release its heat to the slightly colder air above, and I predict pretty much. I think I'm pretty certain. Yeah, I'm correct about this. It has also a mirage type effect because of the heat release. I think it's mirages like that are directly related to heat release of one body of matter uh, to another body of matter that is in a different state, like solid to air or uh, liquid to air. I think that is what causes mirages. So, yeah, that's about that subject anyway.
Hello to
Still
Paul
think,
C. Good to have you here.
hey,
Telex 2010, pleased to have you here as well. Masakuru Alex, have I said that right? MASS.
off air.
Say again?
Wait, it says off air in the Hangout.
Yeah, the Hangout's run by OBS, not Google.
Oh, okay. Well, I don't see anybody else here in the room, so
No, no, it's just us. It's just us till someone else has joined.
I don't see him.
No, there isn't. There's just us. It's just you and I.
Oh, okay. Sorry. So, yeah. How would one determine how flat the Earth is? Well, I say very powerful lasers would definitely help a great deal in determining how flat it is. Because, uh, yeah, if a laser is strong enough, then it will basically create, I predict, a vacuum uh, where it is, and there would be no, there would be no bending, uh, no lensing effect of the air because of its intensity. Would basically, at the first parts would be slightly prone to bending, but as it increases, it'll just and this is like in instantly light speed, so almost uh, it would create a vacuum, and you could like shoot super long distances, perfectly straight lines, and if it's strong enough, it would burn away like what is it, the air which it goes through, so it would leave probably some kind of visual remnant in the moment. If you shoot that, put cameras all over the surface along line its path, and then record as this happened, you would see exactly how it looks, how it shoots away into the distance, and then from the other locations how it arrives and leaves into the distance again. That type of thing would be a great way to analyze what is actually happening there. But it would be pretty expensive to set something like that up. So it's probably NASA budget level, and I doubt they're going to do something like this anytime soon. So it would be a pretty damn expensive project. But hey, if it's strong enough, then we could even determine if it's looping. by basically shooting it exactly west at a certain location, making sure you don't hit anything along its path, and like on top of a really high mountain, for example, and then see if you can basically shoot so far west that the beam would appear past you from the east. You would shoot across the entire uh, width of the spatially enclosed looping dimension that we could technically be in. And if not, yeah, then we'll probably hit a dome or something. But yeah, you would definitely find out if you do that.
Al K from the chat says lasers disperse.
Depending on the strength. Yeah, basic lasers like laser pens, yeah, of course. But hey, if you can like make it like super weapon size, for example, really strong ones, then the intensity would be so powerful it would disintegrate any matter, the air that it goes through, leaving a vacuum which would not cause the light to disperse, basically. That's my theory about it. And I talked to some people a while ago that were really into lasers and doing a lot of research in that stuff, technical guys. And I talked to them and I learned about this concept. It was really interesting. And I think he's now probably working for the military industrial complex. I think he even hinted at that happened. So yeah. Anyway, that's last time I spoke to him is like at least 10 years ago. So whatever. Anyway, yeah, that's my theory about lasers. If it's strong enough, it'll cause a vacuum, uh, reducing its refraction by the air. But it would have to be like incredibly powerful. So okay, I'm in here for 11 minutes now. Anybody else? Yeah. Or any requests what I should be talking about?
If there's a long enough gap, Arwen, I'll do another link and encourage them all to join.
All right. Okay, the Afterlife now asks, do laser work underwater? Well, yes, of course they do. But water is a very thick medium, so it would highly increase the dispersion, making it reach not as far. And yeah, if it would be hot enough, then you would get all kinds of, you would like get boiling water and everything and a mass pushing downwards on that. So lasers underwater don't work probably. Unless they have some special modified type of laser, then whatever.
We've been joined by Charles, otherwise known as Flat Earth Math. Very pleased to have you here, Charles.
Hey, long time no see.
Hello, Nathan, and I don't know how to pronounce your name. Arwen or
Yes, Arwen.
Is it Arwen? Okay, pleasure. I'm still at work. My cubicle at work. The school day is over, but I just kind of decompressing a little bit. So how are you folks doing?
Superb.
Yeah,
Thank you for asking.
Oh, I hear a baby in the background. Mercury just started
I'm,
crawling.
I'm super, Charles. I'll leave you to chat though.
Okay. So Arwen, I do apologize for interrupting. I just wanted to jump in. Normally the panel is
No, you're not interrupting. I was done.
Okay. So yeah, literally I just jumped in. I haven't heard anything from like what you were talking about. So you want to bring me up to speed?
Okay, well, I was talking about lasers, my theory about lasers, how I came to the information basically, and how I think it could help prove the flatness of the Earth and how that would work and how you would prevent typical lensing, all that stuff. I had a very elaborate setup, but it would be expensive, NASA budget level expensive probably, Elon Musk or whatever. But anyway, Yeah, I laid out the experiment.
Okay. Yeah, the problem with lasers, as you well know, is the beam spread.
Yeah,
Um,
I know.
and a one way of getting around beam spread is to sort of reverse the observer, reverse where the observer is versus where the light is. So instead of trying to cast a light onto, say, a surface, like having it be a laser dot, which very quickly doesn't become a laser dot anymore with the beam spread after you get a couple miles away.
Mm-hmm.
Instead of trying to look at the light, instead reverse and put your camera where you would be, where you were trying to get the laser light, and then look backwards. And what you can do, and I don't know, I'm sure you're probably familiar with Jaron's Victoria Canal experiment.
Uh, I wasn't there, but sure.
No, but I mean, have you seen his videos where he's describing the experiment and like what they were trying to do and how they were trying to
Yeah,
measure
I think,
curvature?
but that's like a long time ago. So
No, it was just this past like a week
okay,
ago.
then I missed it.
Okay, so essentially what they had was like I don't know, 4 or 5 mile long canal, and they had these panels like a like a sheet of thin wood, or maybe it was like cardboard or something, and then they had a laser and they were shooting it towards these panels, and they were going to cut holes, a series of holes in the panels, so that the laser would go through them, and then they would try to determine whether the Earth was curved. And I can anticipate what the problem might be. I didn't actually see the results. I didn't see like any videos, whatever, that he did on the results. Is that the wattage? You just lose so much power. You lose so much laser light power.
Mm-hmm.
And so what I would propose is that you would, instead of having a panel, put a light where the panel is. So I think he was having a like a measured line 15 feet above the water surface. And if you just put lights, like everywhere you're going to have a panel, just put a light 15 feet above the water line, and then you observe it. Like, instead of having a laser where you're shooting the laser, change the laser into a camera, and substitute. I mean, and then you just observe the lights. One was at 1 mile, 2 mile, 3 mile, or I'm being approximate with the distances, and you should see a pattern of the light. Is that making any sense? And then
Yeah,
that way you
sure, of course. Laying
completely.
out a pattern like that, especially at night, would help give a lot of to actually work out how the perspective works, because it's very weird how it works.
So, are you familiar with the proposed experiment that Soundly is going to do with Jesse Kozlowski down at the Little Tensas Bayou?
No, I haven't heard of it yet.
So, are you familiar with the Little Tensas Bayou? Do you know? Have you watched any of Soundly's videos that he shot on the bayou?
Yeah, with the electricity masts and everything, that stuff.
No, there are no power lines anywhere near this. It's a causeway that basically, I guess it's in the middle of, say, a swamp, but they cleared out like between the two sides of the highway. You've got one highway running in one direction, I think it's east, and the other one running west. And then they cleared the space between the highways, so everything was like a swamp, my understanding. And they cleared all the floating plant life or whatever, so that you could actually ride a boat from one end to the other. So basically, it's essentially like a 6 mile long lake that's only 30 feet wide.
Okay.
Because that's the distance between the highways. Don't quote me on the numbers, but I'm just being approximate. So you've got a highway that's on pilings or whatever, those slender columns.
Sounds more like a channel than a lake.
Yeah, it's kind of like a channel, but it's the water
artificial.
flows. No. The only thing that's artificial is the clearing of the vegetation. So the water flows freely.
Okay.
It's
you said
essentially
it was right next to a highway, so they probably re-engineered that entire location, and the channel was a part of that design.
No. I think you're misunderstanding. The water level, it's like a large lake, but then they cleared the vegetation from the surface of the water. When you're in a swamp, you got a lot of like swamp grasses and stuff that grow up through the water and on the water.
Yeah, I get it.
So there's no land. There's land obviously on the bottom, but the bridge they just drew pilings into the ground, but the water flows freely. The water flows freely under these bridges, like any other long causeway that's over water. So it is water level. I mean, the water is at, what do you call it? Water level, I guess.
Yeah.
And so what they're going to do is they're going to take a little motorboat and they're going to go to these pilings, for the bridge, which are in a straight line for 6 miles, and they're going to attach flashlights every mile for 6 miles.
Ooh,
At least this is my understanding.
Yeah, that's a good one.
So they're going to attach flashlights every mile for 6 miles. Obviously, when they attach the flashlight, they're going to have like a yardstick or something and measure an exact distance from the surface of the water. And then they'll have an observer at the end observing. I'm assuming it's going to be like 6 flashlights, and then you can see the pattern.
And you could even film it as they go, and then time lapse
possibly.
it.
Yeah.
See what the pattern is. Yeah, it'll also be very helpful, that setup.
So I think that I have high hopes for their experiment. I was hoping that Jaron would add flashlights to his experimental design. I'd sent him a bunch of messages, but he's a very busy guy, and there was a lot of people getting involved in that experiment. So that's a possible future experiment at the Victoria Canal, because it makes it very similar to the Bedford Level experiment done by Alfred Wallace.
Mm-hmm.
Are you familiar with that one?
It rings a bell. Yes.
Yeah. So the original Bedford Level experiment was done by Robotham, where they were like right down in the water. They had a telescope that was just a few inches above the surface of the water, and then they had a boat sail away with a flag on the back, and then they could see the flag the whole time.
Yeah, it's pretty famous, that experiment.
Right, very famous. So what Wallace did, and I don't know how many years later this was, is he got way up off the canal, and he used the canal as simply a measuring device, or he used the canal as a water level. So there at the 6 mile mark, there was a bridge, and then so they put a banner like 14 feet above the water, carefully measured. At the halfway point, they had a post, and then they had a disc. Actually, they had 2 discs, but the top disc was, again, 14 feet above the water. And then at the near end, at the observing end, they had another banner 14 feet above the water, and then as well as a telescope and a surveyor's level. But I think they had a really nice telescope, like a 12-inch telescope or something with a ridiculously large lens. But the point is that everything was 14 feet above the water.
Mm-hmm.
And then when they sighted down from the one end to the other, and they actually moved the telescope and the other end, so they were able to observe at both ends of the 6 mile stretch. The disc in the center appeared to be higher than the sight line to the far, to the far target. So the conclusion that Alfred Wallace drew was that the Earth was in fact a globe.
Okay. Well, that wouldn't be my conclusion.
Sure.
It's still just it's still a perspective effect, as I talked about. Like, the air just lenses it.
We've been joined by, sorry to interrupt you, Arwen.
On the type different.
Sorry, we've been joined by Truth Seeker. If I could just say a quick hello.
Yeah, hello, thank you.
Pleased to have you here. Sorry to interrupt, guys.
That's all right. So I was saying, I still predict that this type of experiment would highly differ in its observations and results depending on the weather conditions and the temperature and the air moistness. So this is what I always say. This is always my end conclusion, and that is, it's all apparent curvature, because depending on the weather conditions and temperature, it's going to be a different type of curvature, and that doesn't make any sense if it's a globe, because then the curvature should be perfectly consistent, always exactly the same. And
Yeah.
we never experience it as such. We never.
Well, that's a very good point, because and we need to distinguish between curvature and the effects that we see when we look across great distances.
Yes.
Those are
Perspective.
two different things. One may reveal the effects of curvature, but it isn't like the definition of curvature. All right, so it's like if you are looking at Chicago across Lake Michigan, you could say, oh, that's curvature, or you could say, oh, that's the effects of curvature.
Yeah. And what is said about the curvature, what it's supposed to be, 8 inches per mile squared, that's never it doesn't seem to be true, because
Well, but
there's been observations during very clear days where thus the lensing effect is the least. There are incredible distances, so much further than should be even close to possible on this 8-inch per mile squared curvature level.
Yeah, well, the problem is when people use 8 inches per mile squared as an obstruction formula, which it is not. And so when you use an actual obstruction calculator that's based on 8 inches per mile squared, you get results that are much, much closer to what we see in the real world. And when I say much, much closer, yeah, there's a little bit of variation due to just exactly what you said: weather conditions, moisture, humidity, temperature, pressure. But those conditions.
It's not 8 inches per mile squared.
Well, no, it is 8 inches per mile squared. That's not the only formula. That's the mathematical
it
basis.
either works or it doesn't. So,
well,
it's very nice that you have this calculator that, like, oh, it uses this, but if it is 8 inches per mile squared, then we should perfectly be able to do it ourselves without any device or formula translating it for us.
Just want to say a quick hello, if I may. Sorry to interrupt you again,
said.
Arwen. I'm really sorry. Can I just say a quick hello to Curved Water? Pleased to see you, Curved.
Hey, everyone.
Hello,
Pleasure
Curved Water.
Good to see you.
I don't think we've ever spoken before. I'm being facetious. So, Arwen, you have a really good point in that you yank out the middleman, but it's really, really important you understand the geometry of 8 inches per mile squared requires that the observer be essentially at ground level, or in the case of water, at water level. And so that you're not going to be able to see very far if you have, like, one of these underwater cameras where you have the lens like halfway submerged in the water. That's when the 8 inches per mile squared is most applicable, is when literally the camera is actually half submerged in water.
No, that's not how that works.
Requires that the observer be at height 0.
No, it doesn't require us to be anywhere, because it is the geometrical formula for the literal curve.
Oh, absolutely.
Yeah, so that doesn't make any sense.
Oh, great. Okay, so that's why I said you got to use an obstruction calculator, which uses 8 inches per mile squared as the sole or as the main mechanism. And if you can indulge me for a moment, if you have an elevated observer and you were trying to look at like, let's say you're looking at Chicago across Lake Michigan, and you're standing up on a 200-foot tall, sand dune or something. Well, your sight line is gonna, you're gonna see the horizon, and that's where the observer height is 0, is where the horizon is. So what you do is you use 8 inches per mile squared backwards to figure the distance to the horizon. Then you use 8 inches per mile squared forwards from that horizon towards Chicago. So you're still using 8 inches per mile squared. That's ridiculous. Well, no, but that's the mathematics of it.
No, that's back calculating.
No. I think you misunderstand, because
that's ridiculous, man.
So 8 inches per mile squared, if you draw a circle and you draw a tangent to that circle, 8 inches per mile squared sort of describes the curvature of the Earth, and it's a pretty good approximation. But that tangent line means the observer has to be literally touching the surface, okay? Because that tangent line is where you're measuring the drop from. So if you're standing on the beach and you're looking out at the water, well, you're no longer tangent to the Earth. You're 6 feet above it. I mean, if you're 6 feet off the water, okay? And if you're obviously on a 200-foot tall sand dune on Lake Michigan, you're 200 feet above the water. Okay, so you can't just simply plug it into 8 inches per mile squared because you're now at an elevated observation point.
No, it
But
should
what?
still work.
Well,
You just change the angle of view, basically. That heightens the distance, but it still doesn't account for the very long distances that you can
yeah.
still
Well,
observe.
the point that I was
It
going to make
doesn't
about
measure up.
those very long distances. First off, you have to use an obstruction calculator, and I think most folks
No, a
agree.
distance is a
Um,
distance.
But once you use your obstruction calculator, you're going to get results that are within a half degree of reality.
This is ridiculous, man. This is absolutely ridiculous.
The curve is the obstruction, so we don't need any obstruction calculation. We need the curve calculation because the curve is the supposed obstruction. End of story.
So, I mean, you can draw this out with literally a circle on a sheet of paper, and you could say, well, where's the tangent line? If you draw a circle and you draw a tangent, the line's touching the curve, and then you plot a point that's above that tangent line, and then you also draw another line. And it seems like what you guys are arguing is that the curvature drop is going to be exactly the same from either, from an elevated observation point or for a tangent observation point, and that's simply not the case.
Okay, here I have a proposal.
Sure.
A way to measure this out. Well, just imagine that the entire known measured Earth surface would be put on a ball. That would be, you take a cross section of that, you scale it down, and then you measure the highest mountain, put that to scale on a certain spot on this cross section of the ball, and then measure the literal distance that you could, where the site basically touches the literal horizon there. There should be a limited distance. And what observations show in real life is that that distance never matches up. You can always see a lot further, or usually, or anytime, which should be entirely impossible.
Well, but
That
be
is what
careful
I'd
with the
say.
word impossible, because what we're talking
You
about
wouldn't
is
be able to
pure
see
geometry.
further.
No, what we're talking about is pure geometry, and what we were talking about earlier in the conversation when we were talking about atmospheric effects and humidity and temperature and things is that these refract the light a very small amount, but up to half a degree in extreme cases, and so that has to be part of the calculation as well.
No, but that's
so the
just
first part of the
optical.
calculation is geometric. The second part is using a little bit of atmospheric refraction, not a lot, just a little.
No.
So
Here,
No, it doesn't bend up. It doesn't bend upwards.
no, it bends the light downwards.
If you would be
Atmospheric
able to see
refraction bends the
farther,
light downwards.
then you would basically demand that this refraction, this bending, would actually bend it up. Because you can
No,
see
it's bending-
further than the literal curve, according to your theory.
No.
Yes.
So if you think about where the horizon is essentially your eyesight or your
I'm not talking about the horizon.
Observation
I'm talking
line.
about the land mass.
well,
That you
sure,
would
but that's
actually
beyond the
see
horizon,
in the
right?
distance.
You're talking about something like, say, a mountain that's 100 miles away. It's clearly beyond the horizon, right? It's beyond the horizon. So the horizon is providing your obstruction, but yet you could see the mountain beyond
That's
it.
because it's not
And-
the horizon. That's a mirage effect. It's not literally like that. It's part of a reflection of what is up there. So part of the horizon, what you actually get to see, is a reflection of what is on the top of it. That's why it seems like there's a piece of air just cutting it off, putting it down, as it were. This is what perspective does.
Yeah, perspective is a little tricky because the actual quality of perspective can never cause something to look like it's in front of something else. It can never cause obstruction.
No, it does. And we have proof of this with footage, camera footage in the distance, zoomed in, and you can see it. It's clearly things being reflected, looking not exactly in the shape as they are, because of this. Parts of boats.
That's refraction. Those are
reflected
mirage
from the
effects. That's not
bottom or up.
perspective. Right. So yeah, I'm very familiar with that footage, but that's not that's not perspective causing, you to see like the boat reflected in the water kind of thing.
Yeah, it is. That's what happens after the first regular perspective limit. Then you get the the mirage effects, depending on the air moisture, basically, and the heat conditions. That kind of determines how close that point is when that starts. And it seems that when it's hot, the point is a lot closer. So you get to see the mirage effects a lot closer up at the at the horizon, basically.
So here's a question, Arwen. Have you ever seen footage of, say ships on the horizon kind of thing, where
Yeah,
there
lots
were
of it.
no mirage effects? I mean, a lot of the footage has mirage
Nope.
effects. I will say that. But have you ever seen footage where there were zero mirage effects?
Nope. It's
Okay.
always there.
It-
It's part of
okay.
perspective. It just depends on the conditions of the weather, how far away this point is, and if there's anything physically obstructing your view. If it's like misty or whatever, then the
Yeah, no,
further
I'm
away
talking about
parts will simply be
clear
obscured.
conditions. That's what I'm talking about. Because
Yes.
I've seen
Then it will
the
still
footage.
occur.
I've seen the footage, and it's fairly rare because mirage effects are so common when you're looking tangent to a body of
It's
water.
always there. It's a natural part of basically of perspective.
Yeah, well, the thing is, but it's never been defined. So when people
Yeah,
use
well,
the
guess
word,
why that is?
well, anybody's free to define it. It's a free country.
Yeah, but it'll get
know,
in the way of the
I mean, this is a free
globe.
conversation.
So
You know, so it's a free. Anybody's free to define. Like people invoke the name perspective, and well, it would be nice if somebody defined what it was.
well, I do. I've been doing that right here.
Well, but it seems like what you're describing is the curvature of the Earth.
No,
Like
because
when
that's
we
not
things
what curve
we see.
looks like.
Well, you could say that's not what it looks like, but then you're going now against expectations, against human expectations.
Yeah, that's always troubling, isn't it? People don't
Yeah.
like that.
So one way to cut to the chase is to say, why don't we measure curvature using instruments like a theodolite? Have you ever heard about how you can actually measure the curvature of the Earth using a theodolite?
Nope.
Okay, well, it's pretty straightforward. You take two stations and try to get them a couple miles apart. I mean, they don't have to be extreme distance apart, but like maybe 2 miles apart would work pretty well. And what you do is you shoot a sight line from one station to the other, and then you measure what they call the zenith angle. So it's the angle that is formed between a point straight over your head and that station, so that it's probably going to be pretty close to 90 degrees, maybe a little, fraction of a degree more, fraction of a degree less, depending on elevation. And then you go to the other station and you shoot, I think they call it a back azimuth or something, or a back sighting. And then you measure the zenith angle, the angle formed from the point straight over your head to the line pointing towards this other station. And again, this angle will be very, very close to 90 degrees. But what happens when you add those two angles? Well, if you add those two angles, it should add up to 180 if the Earth is flat. And if the Earth is a globe, then it should add up to
You would
slightly
actually
more than
need to give
180.
me some visual aid because I lost track.
Okay. I don't know if I can.
And I mean, like, literally show this on a video
And
because
it
that
would
was
it would help
way
too.
too much.
It would help too if you had any kind of firsthand experience using a theodolite, if you're a surveyor or anything. Because every time a glober tries to use the theodolite as an example, we ask them how the machine works.
Yeah, I'm just going by what I learned from Jesse Kozlowski. But there was a YouTuber, I think he was called Red Pill World, and he made a 5-video series where he started the video series seriously thinking that the Earth was flat, and then so he shot some observations. I think it was on Lake Michigan towards Chicago, and measured very, very precisely using the surveyor's benchmarks, shooting towards Chicago, and then he ended up the series concluding that the Earth was in fact a globe because of his careful measurements. So no, I've never used a theodolite. I just go by what I know about them.
Looks like this is an opportune moment for me to do a few links. So, if you are new to this channel, or you are one of the 50% of the people who are not subscribed already, be sure to hit that subscribe button and the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show, and I have been periodically spamming the chat with Shilscanner's advert for that super chat link, so hit that super chat if you'd like to support the show. And most importantly, if you would like to join the debate with the page that you are watching currently on mute, simply click on the link in the info box below this video to join the show and express your views on the shape of the Earth. There are, however, a couple of rules in the Hangout. Number one, please do not swear. If you do swear, you will be ejected, but if you are, you will be warmly welcomed back on the next stream, so please do not try to rejoin the show using sock accounts. If you've not done so already, please share the show on social media, and a massive thank you to all of you who have done so already. Once more, if you are new to this channel, or you have not done so already, please subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
Where he was measuring the curvature of the Earth, or at least he was recording that the Earth was in fact curved in as little as like 200 yards. But it was, he was right at the limits of his instrumentation, so he wasn't able to get an accurate reading. But he definitely got a reading that the Earth was not flat.
Sure.
So, but that's, what's interesting to me is that flat Earth folks, they love doing these experiments, but they won't actually use the tools for the job. So like a theodolite is designed to make extremely careful angular measurements, and that's ideal for measuring the curvature of the Earth.
Okay, well, yeah, I guess you're right. I guess that flat earthers should probably, at least some of us that can pay for that type of stuff, should do something like that just to check it out. I don't know, like, what you really need for such an experiment.
Yeah, and you can rent the theodolite fairly expensively from a building supply house. But there are a bunch of I don't know, truisms or at least repeated claims, such as the horizon rises to eye level, and these things are very, very testable with instruments.
It's what you depend. Well, you're breaking up, Truth. It's terrible. Anyway, to reply in that, what I declare is that the horizon, what is now currently basically taken as what the horizon is supposed to be, is actually the line where what we see as the air or the things above is bordering what is beneath that. But what I'm saying is that by nature of perspective itself, it will always be a little bit down of the actual literal position, because of the perspective effect that reflects what is on the top of the real horizon downwards as a mirage effect. And this will always be visible in the distance everywhere, unless it's physically obscured by mist and the likes.
All right. Would it be wrong of me to ask for you to explain what you're talking about with this footage here that I'm showing?
Yeah, that's exactly what I'm saying. It's mirage, clear as day.
All right. Well, can you point out the mirage?
Well,
the mirage occurring here. You know what the ship looks like, right?
It's blurry as hell.
Yeah.
It seems to be very vertically blurring. It's like a bunch of vertical lines.
Arwen, do you see the size of the ship?
Yeah. And look at the bottom part there. Look at the bottom part. It's wobbling all over the place. It's all smeared out vertically.
Do you see the size of the ship here, Arwen?
Yeah, it's very big. And it's pretty close by.
Go from there based upon what you're describing. Can you explain it to us?
Yeah, well, depending on its height, and cruise ships are pretty damn high in its totality.
Yep.
Depending on that, if it's not too far away, like really far away as these windmills, I presume they are, then you would see just a blurred bottom part, and the rest would just be plain visible without any blurring.
Can you tell me where the rest of the ship is in this image?
Here, I
Is
don't
the
see.
ship? Yeah.
Where's the ship here? I don't see
Now
it.
if he zooms in on it, notice it. No more of the ship comes back when he zooms in.
I don't know what you're
So
talking
what's
about. That
going on
blurry
there?
thing over to the right there?
The whole thing, that right there is the ship. Remember this ship here?
No. Is that
This
it?
ship.
Oh, okay. Yeah.
It's
Then
this
it's probably
boat.
turned its back. It's going towards away from us. So yeah, then the further it goes, then it should completely have that effect. What you're seeing. Oh wait,
And
it's like the top part of it. So it's
yeah,
not
you're
a
just seeing the top of it. You're only
wow.
seeing the top.
Didn't
There's
realize
a
that.
huge portion of the ship that's missing.
Yeah.
That's why I like to show this. So what do you think?
Well, I think exactly what I said. It's like this is all blurry remnants, as it
Is
were, of the
is this
top
water?
part reflecting to the
Is
bottom.
this water blurry? Is that water blurry?
No, the water is the action is what like in front of it is
Okay.
the first horizon.
So
Yeah, that's
the top of the water.
after that point there the mirage perspective goes. The actual physical horizon should be well halfway this image.
Where
Roughly
is the
there.
mirage effect here? What
Everything
mirage?
above what you see as that watery wavy part.
Everything above that is mirage.
Yes.
So you're saying the ship itself is actually completely blocked by the horizon,
Right
but
now
due to
it
a
seems to be,
mirage,
yes.
part of it's lifted up above the horizon,
What you're seeing here
pulling
should
it into
be
our
a
sight,
mirage effect of the
rescuing
upper
it.
part being reflected downwards.
Okay. All right, Arwen. Thanks for trying. I'm not going to ask you to think about this anymore.
Oh, I have no trouble doing it. So sorry if I've given you a headache.
Yeah,
So,
you've given me no headache.
It happens.
sorry
Okay, Charles.
for busting in, Curved, but
No,
Arwen,
do it.
one of the things that you can do with a, and you can even do this with a dumpy level, you don't need actually a theodolite, is you can make sightings from your observation point towards that, say, that cruise ship, and you could aim at the top of the mast, you can aim at the horizon, and then you can have a reference picture for what the cruise ship actually looks like, and then you can actually shoot where the water line is, which is obviously it's obscured in that image. And what you find is the cruise ship is physically lower. I mean, it is absolutely lower than where it would be if the Earth were a plane. It's significantly lower, like hundreds of feet lower. And so that's why we have that water horizon obscuring, a good 2/3 of that cruise ship.
You say so.
And that's very much predictable with globe mathematics, and you can even include a little bit of refraction.
It, really.
What did you say?
I don't believe you.
But my whole point is try to make careful measurements, because oftentimes people make casual measurements. So they'll say the horizon rises to eye level. And I know you don't say that, but the horizon does appear to rise to eye level. But if you get an instrument,
but
you can
it's
actually
slightly
measure
below, or slightly
below,
above eye level because of the perspective effect that causes the mirage in the actual horizon to be like the upper part of the real horizon is reflected downwards.
So what do you say to when you increase your altitude, the horizon dipping even further below, which is absolutely not what would be expected if the Earth were a plane. No, it
doesn't do that. It goes down to a certain point and then it stays at that point, despite if you keep on going upwards. That's what happens.
No.
Yeah.
Well, the thing is, but measurements say otherwise. So real world measurements.
No, I've seen videos of that. Eric Dubé.
Well, but when you say you've seen videos,
and he was right.
Well, when you say you've seen videos, were they videos that were shot using instrumentation?
Yes.
Like a theodolite, where they were actually measuring
upwards. Very early work of Eric Dubé, and he was right. Explain it in detail. That's exactly how it works.
Okay, you said very early work of Eric Dubé. I don't know if he's ever used instrumentation in any of his videos.
Well, you don't consider balloons with cameras as instrumentation?
No, that's what I would call casual observations. If you have a balloon with
Yeah.
a camera,
Yeah, sure.
Yeah.
Yeah, well, it doesn't
Arwen?
explain how the apparent horizon even, after a certain point, doesn't drop any further and just keeps on ascending with you slightly below the literal horizon.
yeah, but here's the thing, Arwen. If you have a balloon and you put a camera on it, there's no precision in that. I mean, you might get wonderful footage, but you
Bullshit.
have no
I'm done
precision
with
and you
this.
have no measurements.
No.
Right? And that's really the
No,
point I'm trying to make,
doesn't make
is that
any sense.
if you get precision measurements,
No.
I mean, otherwise you're just going to get some really great footage. I mean, I'm not going to, fault the footage. The footage is probably beautiful.
Yeah,
but
if you
wouldn't be able to
ascend,
see.
then eventually the horizon will stop dropping, and that's just it. And
But
you
how
can't
can you
like
tell this?
use measurements and everything to account for that at all.
Yeah, but what we're talking about is using a casual observation, right? A camera hanging from a balloon, and like every single one of these pieces of footage, that there's a little bit of bobbing around. I mean, you can't say that the horizon is exactly 3.7 degrees below eye level. There's no.
If you
That's what
compare
I'm
them
saying.
all, yes, you can, and you can measure it out.
How can you do this with a camera just hanging from a balloon? How can you measure this angle?
Well, eventually it'll stop dropping, and that's conclusion on its own.
Well, you say
Otherwise,
stop dropping, but the camera is bobbing the entire time.
That doesn't matter. Doesn't matter how much it bobs, even if it makes it completely blurry. If it's actually a ball, then if it goes up enough, then the horizon should constantly keep dropping.
But how are you
rate.
measuring this drop? If we have a bobbing camera hung from
because
a balloon,
of an altitude
it
meter.
has not been.
Now, the comparison to what you see down there and what you see up there should be very clear. The sky part should be growing of the entire footage. Very clear ways to figure that out.
All right, so I guess we differ on what
apparently,
instrumentation, what instrumentation means, but
yeah, well, observation can bring you very far. And point
right,
out
but careful
things
observation
that you can't overcome with instrumentation and theory.
Well, but careful observations get you further than casual observation.
Sure.
So, it's kind of like you want to measure the length of, of a hallway, and you start walking down the hallway going heel toe, counting your footsteps. And meanwhile, there's a guy saying, hey, wait a minute, I've got a tape measure. And you're like, no, I'm counting feet, right? I'm counting feet. It's feet's a unit of measurement. And it's like,
comparison.
Well, but one is a casual,
casual
measurement, and the other one is a careful measurement.
No.
So all I'm suggesting is that if you have an elevated observer and you have some kind of instrumentation, either a dumpy level or a theodolite, you can actually measure the drop of the horizon below eye level.
Yeah, that's very fun.
And this drop of the horizon is 100%.
Observations of balloons when they go up high enough.
I've never seen a balloon carry any such instrument. So until that time, we can only just talk about what it looks like, but we can't talk about what it actually is.
Doesn't matter what this device does of yours. It doesn't account for the observations, the basic, measurable, repeatable observations of all these balloons going up.
Did you just say measurable? So.
Hey, so this is going in circles. I got something decent that I found out today.
All right, Truth. What do you got?
I was on a hangout. I don't know what channel because I don't follow them. Reds something. They were basically trying to debunk the flat Earth. 10 people, all globe. Of course, nobody supporting. Debunking the globe at least. And so I had them start off. They were talking about a theory similar to Occam's razor, where you go with the theory with the least amount of assumptions in it. And I'm like, hell yeah, that sounds good to me. So we got to at least admit that theories loaded with assumptions are less credible than ones that don't have as many assumptions. And then we started to boil it down where they were convinced side had more assumptions than the globe side, when we could actually tear it apart, we got them to admit that regardless of frame of reference, we're stationary and motionless, and that the globe clearly has more assumptions given that frame of reference, that all observations prove we're stationary and motionless, regardless if you think we're moving.
That's very interesting, Truth, except for all observations don't show that we're stationary and motionless.
No, because I had
Casual,
them actually.
casual observations, sure, but not careful observations.
Yeah.
Okay,
sure.
well then I had them at least admit, regardless
It's
if they
nice
thought it was spinning.
category. Nice categorizing. So, if it could actually be very easily done, and if it would actually show that it's flat, then it's casual observation. But if it's some kind of cryptic measuring system that's very easy to tamper with, then it's real. It's nice.
Yeah, so real quick though, then you're right. I agree with Arjun 100% on that. But I just wanted to bring up the point that they are often hanging their hat that they're running with the theory with the least amount of assumptions, and they're claiming that yes, all casual observations prove that we're stationary and motionless. Well, then that discredits their first argument, because the one with the least amount of assumptions would go, we're a stationary, motionless plane, rather than inserting curve, spin, speed, all these things.
Yeah, absolutely, and that's where we were, say 3,000 years ago. If you look out at the horizon's flat, right? We don't feel like we're moving. It looks like the sky is moving above us. It looks like the sun, and the moon are orbiting us. So absolutely, the Earth is flat and the sky moves above us. That's you got no argument with me there. But then once you start inventing tools that you can start doing some measurements with, and the first tool could be something as simple as a protractor. You don't even need a telescope. You just need a protractor, and you can build a protractor just by taking a piece of paper and curving it into a semicircle. And that's when you can actually start making real careful observations. Again, you don't need any optics. You don't need a telescope or camera. You just need a protractor. And if you track the sun and the moon, right, sun and moon and stars, you'll see that they trace a spherical sky, a celestial sphere.
Okay, I would agree with all that. All I wanted to let the record be shown is that the globe theory actually has way more assumptions loaded into it than a flat motionless plane theory. That's all I wanted to show. And these globe people on this other channel, these people on the other channel were trying to hang me, saying, "Oh, look at all these assumptions. He's loading in all these assumptions. Ours don't have these assumptions."
Well, but Truth,
like, yeah, yours has way more.
But truth. If you restrict yourself to waking up in the morning, looking out at the horizon at the beach and saying, hey, it's flat, and then like feeling the earth beneath your feet and saying, does this feel like it's moving? No, it doesn't feel like it's moving. If you restrict yourself to those two observations, absolutely, the earth is flat and motionless. Absolutely, no argument. But as soon as you start actually observing things, that's when the flat earth theory completely falls apart. Because the flat earth theory...
I've seen great footage.
Well, just let me finish. Just let me finish the sentence. The flat Earth theory cannot account for a spherical sky, a celestial sphere.
No, it has nothing to do with it. Because the heavens are holographic.
No, literal. I even got the globe.
Bodies out there.
Got the globe people to admit that
you're breaking up, Truth.
And they agreed. They agreed that. All of their theories had more assumptions. That's all I want.
Okay, we got it. Anyway, the flat Earth cannot account for the spherical nature of the heavenly bodies, but that's only if you are using a baseline assumption that the heavenly bodies are physically literal.
No.
I'd say that it's holographic in nature, and it's always in relation to the observer.
Well, but the observers across the Earth, and now first of all, I'm not talking about the moon is round and that planets are round. I'm not talking about that kind of sphere. I'm just talking about the heavens, how they appear to move in a spherical fashion, meaning we have a north celestial pole, we have a south celestial pole.
Well, we're not entirely sure of that even.
Well, but talk to the people in southern
hemisphere.
I'm not
sure about trickery over there. So there could be a south celestial pole, but I actually want to do some more digging before
Well-
I make that baseline assumption even.
So,
But
but it's
the
not
heavens
an
could also
assumption.
be a
If
cup.
you have an observer in the southern hemisphere looking south, looking due south and looking at the southern sky, and there's tons of time-lapse footage, that you can get, and there a bunch of it has been recorded by
from
flat
NASA, I
earthers,
don't trust that at all.
right? Well, no, I mean, well, do you trust the ones that are recorded by flat earthers? But there's tons of footage of people seeing the Southern Cross, people seeing the pointer
Cool.
stars.
Link me up with some of
And they're
that.
rotating around a point in the sky. Now, there's no
Link
bright
me up
star
with
at the
that.
center.
Because I
sorry?
haven't come across much of that, really.
Well, just take a look at any time-lapse footage that includes, say, the Southern Cross. So just type in time-lapse stars Southern Cross, and you'll get hundreds. You'll get hundreds of examples, and every single one of these shows the stars to be rotating in a clockwise.
So we've just come up on the hour mark, so I'm going to do a couple of quick links. A massive, huge, enormous thank you to all of you who have shared the show. If you've not done so already, please share the show on Facebook, Skype, Twitter, and all of your social media platforms. If you're new to this channel, or one of the 50% of the people who've not done so already, please subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. Most importantly, if you would like to join the show to express your views or dispute anything that is currently being said on the panel, simply mute the page you are currently watching and click on the link in the info box below this video to join the show and express your views. The only rules are please don't swear. If you are swearing, you'll be ejected and you'll be warmly welcome back on the next show. So please don't try to rejoin with sock accounts. One more time, if you've not done so already, please share the show on social media and subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
Actually, the smallest constellation, because it's got these four, actually it's five, bright stars in a very tight formation.
Mm-hmm.
So of all the 88 major naked eye constellations, it's actually the smallest one. So it's very, very distinctive.
Haha. Okay,
Alright,
I'm looking at
my
the
main-
footage right now, and this is not a center point at which this thing is moving over the horizon. Basically, very how do you say, like the curve? There is some kind of curve in its movement, but it's absolutely not anywhere near the center point.
I never said it was near the center. I said you'll see the Southern Cross rotating around an imaginary point, which is the southern celestial.
Around an imaginary that point, if I take this curve, should be like directly under the observer here. So
Well,
that's
so might I
problem point
suggest
around which a globe is rotating, really,
might I
at
suggest
all.
that you take a look at as many pieces of footage as you can.
Well,
Obviously,
this one is
now
really
in a
good. I'll
Hangout,
post it right here.
But there's just a bunch of them. There's a bunch of them, and then some are good and some are bad. And there's actually ways that you could fake star trail footage. So
Well,
you have
take
to
a
be
look
careful of that.
yourself. This seems pretty
Yeah, can
real.
we define how this is impossible on a plane? Because I don't understand where he's getting at.
No, this is very possible, and even on the plane, it doesn't matter because
No,
the
I understand.
heavenly bodies
Arjun,
are
I agree with
holographic
you.
anyway, so it
I
doesn't
wonder-
matter if it's a globe or a cup.
Exactly, Arjun. That's my point. Is he's not proving either or with this evidence.
I know.
So first of all, that footage, just from I haven't even looked at the caption. That appears to be shot from the northern hemisphere, looking south.
Oh, really?
Well, I mean, I don't know. Read the caption. Where I don't know where it was shot, but that's what it looks like because it does appear to be moving around a point that is below the horizon. So what I would suggest is that you find southern
Point
hemisphere
below the horizon. Are you serious? Look at the rotation angle there. That's not a
I am
point
looking
below
at
the
the
horizon.
rotation
That's almost 90 degrees.
Okay, it
away from
appears it appears to be, things rise in the east and they set in the west. So it appears as though we are looking south from a northern hemisphere perspective. Okay, it's from the equator. Okay, that's the caption. It says from the equator.
Okay.
Right?
Okay, that explains.
But it actually doesn't. That's
well, then
it
it's
doesn't
not.
appear to be
Then
shot from
the
the equator
cross
because
is not at the center point
the
of the
southern-
south pole of this imaginary globe of the heavens, because this is the cross. What they're pointing at here.
Sure. They're
And
they're
rotating around.
right. Well, might I suggest that you look at one of the other 100 videos of showing Southern Hemisphere star trails. Okay, that is not a very good one, especially since even the caption says it was shot from the equator. Why don't you find one that was shot from Australia or South Africa?
Wouldn't the equator be the most ideal place to take these images? Come on.
Well, how many people live on the equator? And the thing is, what you're trying to find, what I'm trying to get you to find, is that if you observe the stars from the southern hemisphere, the observation pattern mirrors the observation pattern of northern hemisphere stars. Not the same, but mirrors. So we have our Big Dipper.
Yeah, and that's not like a trick or something.
Counterclockwise around the northern celestial pole.
That's not a trick. It's not a mirror image, basically.
No, it's not. It's not a mirror image.
Very trick to do. Come on.
I'm just saying that it's parallel to our observations.
It's
so just
very
if you want to do a real quick math.
That's what it is.
So, for example, I live at 40 degrees north, and the northern, the Polaris, is exactly 40 degrees above my northern horizon. And if you take somebody in Sydney, I think that's around 30 degrees latitude. Well, the southern celestial pole will be 30 degrees. I'm sorry, it's not 30 degrees. Yeah, it'll be 30 degrees above their southern horizon, right? And it matches perfectly. Just take your latitude, and that's where the celestial pole is going to be above the horizon. It doesn't matter if you're in the northern hemisphere or if you're in the southern hemisphere. And that doesn't make any sense if we live on a flat plane where there's only one center of rotation. It doesn't have anything
to do with the flatness of the Earth, what we see in the heavens at all.
Well,
how that implies anything.
Except for the fact that you've got observers all over the Earth who are all observing stars at the same time. All right, that's the key. If everybody on the flat Earth is looking south and they all see the same celestial pole and all the stars rotating around it, well, then they can't all be looking in different directions. They're all looking in the same direction.
No, it's holographic.
It's holographic.
It's holographic. It doesn't matter where you are. You always get to see what is out there in accordance to your location. It's all relative to the observer anyway. If everyone over the entire world, flat Earth, planet, whatever you want to call it, would all at the same time do observations and measurements of the heavenly bodies, you would all line up all that data in one single stroke, then none of it would make any sense, because the moon would be all over the place. It would make any sense at all if you'd all take it literal.
It actually makes 100% perfect
no,
sense
it doesn't.
in the heliocentric model. And
no,
if you think it doesn't,
no,
then
not even close, man.
The heliocentric model.
Even
it
close.
Makes zero sense. It literally makes zero sense.
It literally makes zero sense. Well, then you don't understand the model. You don't understand the model, because the observations that you can make of the sun, moon, and stars will be at most, under extreme circumstances, a half a degree off from where the item should, quote unquote, be.
And that's talking about the theoretical model. I'm talking about physical observations.
Yeah, no, the physical observations.
Those observations.
Things are exactly where they should be.
No, they won't be. The moon is not. It rarely is.
What do you mean rarely? Have you ever used?
And it doesn't line up with the heliocentric concept at all.
I'm sorry. What'd you say? The moon
doesn't line up with the heliocentric path at all.
It lines up 100%. And I mean, I've spent 10 years, well, 9.5 years studying this. All right. I've literally spent all this time studying the flat Earth and then the heliocentric model, and the moon 100% lines up exactly with where the heliocentric model predicts it'll be. So, for example, it is now, there was a full moon a couple days ago, and it's now approaching winter time in the northern hemisphere, and the moon is as high in the sky as the sun would be if it were noontime in the summer. You know, and it's like, that's pretty cool.
Why does it rotate around its axis exactly aligned to the observer?
Well, now we're getting into the why. You know, there's a lot of things that we can't explain. I mean, I don't want to explain that.
Yeah, but that doesn't work, because you can emulate. You can emulate this with your physical, literal models.
Sure.
And that does
you can
not
emulate it.
match what you would see on that model. Whatever your techniques are, it's not going to match what you're going to actually see out here in the sky.
I don't understand what you say, but it won't match. First off, if you actually build a physical model, and then you have the one face of the moon facing towards the Earth at all times, it absolutely will match. It would be tough to construct an actual physical model because the sun is really big and really far away. But you could at least construct the Earth and the Earth and moon.
You can ray trace it. You can.
Sure, you could build a 3D model,
and
all these softwares like Stellarium and all these other astronomy softwares, they literally have 3D models, and you could light them from any direction. Yeah, and it absolutely matches up. And you could do it yourself. You can use Blender or you can use Unity. You can actually.
I know. I did some experience myself in the 90s with my very early Amiga 1200 computers with ray tracing.
Okay.
And the interesting thing was that whenever I tried to actually emulate on short term a cosmos or whatever, would always look very science fiction. It would never even come close to the actual observation on the Earth, even if I used a bottom part. Can I please finish?
Sure.
But
sorry.
There was a very specific program outside that you can introduce to emulate the entire heavens to make it look exactly like it did on the Earth. That existed even back then in ray trace programs of the 90s.
Don't tell me off. I'm going to interrupt you now, Arvin. I'm really sorry. I'm just going to introduce Jibby Jedi. If you can give him a few seconds just to get on the mic and say a quick hello, if you don't mind. Just pause just while he says hello.
Hello, this is George Takei to tell you that the Earth is flat.
Thanks for being
We
here.
agree.
Good to see you.
Kind of.
Good to see you.
Okay. Anyway, I'm gonna take a smoke break. So keep it flat, guys.
Burn him if you got him.
Hi, Charles. Chuck. Chat.
Hello. So, Jibby, you'd be very surprised. I have a very vivid dream life. And last night I had a dream that there was some sort of event, that it wasn't exactly a formal event, but there was a bunch of people there. And then, people start, going their separate ways. And it ends up that it was you, me, and then my sometime quasi-girlfriend, Ellen. And then so we were going to go our separate ways because the event was over. And I was thinking to myself, you know what? Hey, why don't we just go to a coffee shop and just kind of hang out? And so I was just thinking, just like really positive thoughts in your direction, Jibby, because at some point you and I will sit down at a coffee shop and just shoot the breeze. And I just feel a kinship towards you. So I just wanted to let you know live on TV.
If you ever enter New England, you get in touch with me. I'll make the drive to whatever state you're in New England.
If I could just make a couple of quick introductions, guys. So we've been joined by Epistemology for Truth and P. Mars. If I could just get Epistemology to say a quick hello first. Hello, Epistemology. Good to have you here.
Yeah, thanks.
And also P. Mars. Hello to you.
Hello.
Good to have you both here. Sorry for interrupting.
Charles, did you? You saw my article. What did you think about the math?
It's a very, very easy mistake for a layman to make. I wasn't familiar with the 8 inches per mile squared either before I entered the flat Earth debate arena. So yeah, he just got his numbers wrong. But he's a reporter, not a math and science guy. And
yeah, he said that I said, where did you get that math? We told you the math like 500 times. He's like, oh, well, it came in the editing phase. And he's like, I'll talk to my editor to see what happened. And I was like, okay, well, I don't know if you guys are going to put a correction out or whatever, but I'll do one on YouTube. And we'll see how it goes. I said, the math that you gave them also states that there's no curvature. It's just a slope. So it's like it worked either way. So that it's not a ball.
It was a very interesting article.
Well, I gave him the human story because he really wanted that, because he was like writing this up and he wanted something interesting, because just regurgitating facts or whatever, it's just he wanted, like, all right, how's it impacted you? How has it impacted your life? So I gave him the human story. he gave me fairness in reporting flat Earth. So win-win, I figured. Gave me what he wanted. He gave me what I wanted.
Yeah, I'm very glad that you're pleased with the results, because the story was mostly about you, and it's really easy for the reporter to get it wrong. So I'm glad that you're pleased with the results.
Yeah. It could have been worse. We all know it could have been worse, but it was fair and neutral, except for the equation math mistake. But yeah, I thought it was good. When I saw you in here, Charles, and I'll let you guys get back to it in a sec. I just wanted to, this is just a little hit and run kind of thing I wanted to do here, real quick. We all understand how shadows work, right? This is the SpaceX CRS-11 landing. And, of course, we all know this is what real live photography looks like here. But I just want you to notice there's no shadow. Look for these little fellas when they land. There's no shadow on the ground. I was paying close attention to these things. I figured I'd zoom in a little bit and check it out. No shadow.
So Jibby, have you ever been outside on a bright daylight day and not seen crisp shadows? Has that ever happened?
No, I see shadows pretty good. This is the day. This is the bright day. Yep.
Right, but does it look like there's a clear blue sky?
Well, there's no shadow here either. Like even when
does it look like there's a clear blue sky? Because I could see a faint shadow towards on that one still shot. It was sort of at the 9:30, 10 o'clock position on that other shot.
Let's see.
But I mean, if there's, do you see what I'm talking about? And I don't know if that's the actual shadow.
Let's take a look.
Been joined by a couple of new guests.
Oh, I see one going this way. It looks like.
Right.
Sorry to interrupt you guys. Can I just say hello to our new guests? I'm really sorry. Can I just say hello to Mr. Miss? How you doing, Mr. Miss?
Hi.
Good to have you here. Very pleased to see you. And we've also been joined by David. Pleased to have you here, David.
How y'all doing?
Very well. Very pleased to see you. Thanks for being here. Sorry to interrupt, Jibby. I'll put the screen share back on you.
Jibby, are you a member of any fraternal orders?
Hoping to be. Yeah. There's the Freemason Lodge in Boston. Carl and I were gonna go in there and apply and say like, hey, we know the Earth's flat. Can we jump to 33rd degree?
Every panelist must divulge all occult activities and secret societies, please.
Oh, you faded off. I didn't catch that last part. I was just playing around with these SpaceXs, looking for some, those cloud patterns and stuff that they seem to reuse. And it was just such a pain because I found a beautiful cloud pattern in the Falcon 9, the successful landing that was shot from the ocean. But unfortunately, it's the only shot that was taken that way, except for the crash. So there was the crash and this is a successful landing, and that was it. And then, of course, the camera goes out every single time.
But you know that people, like tens of thousands of people have seen the landings, right? Red Rhetoric went out and filmed it.
You know that
P900 while also filming on his GoPro.
Tens of thousands of people don't see a landing on a barge.
Yeah, not on a barge.
I've seen satellites launch. Doesn't mean they're real.
There's plenty of missions that have come back to
You do see them from far, far away.
Yeah, that's fake as hell.
Was the moon landing real?
All right, so everyone on the panel, I do have to bid my farewells. I do have to go. Jibby, I'm so sorry to cut this short, but I actually have to get home to my wife and dear children. We will have to set up a hangout at some point. So shoot me a line, an email, and we'll have to coordinate something.
Yeah.
Just take that fake ball when you get there too.
Thanks for being here, Charles. It's been a real pleasure, as always.
Yeah, take care, man.
Thank you so much for hosting, Nathan. Take care, everybody. Bye-bye.
We had to get in here. It's round 50 right here, guys.
Round 50. Yeah, I had to come by for
It's
that.
round 50 right here.
Ding, ding, ding.
We know we keep
Ring the bell.
ding ding.
The bell was rung a while ago.
Yeah, it's been
Long
rung.
time ago. Round 1, knockout. We won. Yay.
So
We did.
it just needs to be made that the ballers do not have a map. You know, we got to get on here and say that they have no proof on the ground. Even Einstein said that. They were talking about how Einstein said there's no way that you can prove on the ground that you're on a spinning ball. So they got 2 major hits against them right now, and I just everybody out there that's thinking about or are a flat earther need to know where there's people standing in their corner on this deal.
Is that what Einstein said?
Einstein wore women's clothing too. So.
Do you have a citation for that, David? You seem to have that quote a little bit screwed up.
No, they were talking about that. That was all. Just go back to last night's debate, and you'll hear it.
Einstein
what did he
was like
say?
Matt Lauer and Harvey Weinstein. He used to answer a door in a trench coat and flash young women. And if they would, they'd either run away horrified or sometimes they would bang him.
The point here, it doesn't matter if Einstein was a Martian. The point is, David Blackson is quoting him, and he's quoting him horribly. It's a terrible misquote.
So there's no way to prove that Earth spins on the ground, is what he said.
What did he say?
Y'all said. That's what the baller said.
David,
the baller said last
what
night.
did he actually say? If you're going to quote somebody, quote.
I don't know the exact quote. I'm quoting what you said last night. That's what you said last night. That's what they said last night.
They said, okay, not me. They.
Not you. You didn't say.
Don't say me.
I didn't say you said it.
That's right. All right. Why don't you run along now and look up your quote and at least quote it correctly? Quote it correctly. That's it.
What you need to quote is you need to go ahead and tell us how we can prove the Earth spinning on the ground.
David.
Let's get started. He was
Why is it the same questions every single day, and we spend hours answering them, and then we come back the next day, same question again?
Exactly. See the point? Because you don't ever answer. It's just like showing those star trails down there and all that. You come up with the same stories, but none of them. Everything's from outer space. You don't have any proof on the ground that we live on.
If it ain't done in Texas, it ain't right.
David, I would say the fact that we can predict eclipses for hundreds of years to the second and paths of totality to, within a couple of 100 feet is pretty good indication that we have a working model. What would you say?
The sun and the moon go equal.
Clock.
The heavens, man.
You got to work
with a working clock with no parallax.
The flat earthers have no explanation of that. They have no way. They have no way to model that. They have no way to make.
Yeah, they have.
They have no way to show
astrological
anything.
charts, and they've been around forever.
If it works on the ball, it works on a plane, man. That's the way it is.
Hold on a second.
If it works on the ball, it works on the plane.
Erwin, in the ancient days, in the old days, they could predict that an eclipse may or may not happen in a given year based on a mathematical pattern, but they could not predict it to the second. They could not predict the path of totality. They had no idea where the path of totality.
And they thought the Earth was flat. Ding, ding, knockout. They thought the Earth was flat back then, man. So you're telling the story on way back in ancient times, and so there's a knockout. So we did it.
Get on a standing 8 count.
We could avoid a lot of arguing if we just stayed away from. Well, this one said this, and this one said that, and this one said this, and this one said that. Let's not work with hearsay anymore, and let's try that.
Well, Jimmy, you know that it's not hearsay that flat earthers have no way of calculating eclipses, right? That's not hearsay.
No, the farmers had a way when they were flat earthers.
No, there was a mathematical pattern that you can use to predict where a year that an eclipse may happen.
What is the math?
Uncertainty.
What is the math behind that?
Let me pull the. There was a few. Basically, what they did is they tracked the eclipses for a very long period of time, and then they looked for patterns in them, which there is because. This is a rhythmic type of event, right? Based on the orbits of these things.
Behind it, like
I'll try to find it for you what they were using in those days, but they could not predict it to the second. They couldn't even predict it with 100% accuracy, and they sure as hell couldn't predict the path of totality.
Okay, how do you know that though? Like, where did you get that information from?
There is nothing in the text that ever showed that type of precision or ability to predict it. You can show me one piece of data that they had that type of ability. I'd be very happy to see it.
Yeah, but you're still getting the same information from like secondhand. It's just hearsay. Like nobody knows anything.
Yeah, well, anything that happened before I was alive is going to be secondhand and hearsay, right?
Let's work with what we have while we're alive here and now, and maybe we'll.
That's like,
Why
oh,
don't we
that's
just
great.
admit that they lied to us and we don't live on a spinning ball? Why don't we just admit that to yourselves and we'll get along a lot better? You just got to,
David, I don't
you got to
even
face
think
face it, man. Just
David, I don't
face
even
it. The
think that
Earth's
you're for real,
flat.
David. I think
it's
we
level.
figured out that this is just a trolling. This is a troll fest for you. I get it.
It's a flat Earth troll. I am a flat Earth troll.
It's just
You're
a troll
right
fest
about
for
that.
you to get an illicit response out of people. I don't actually even think.
Yeah, we got. Yeah, I'm a flat Earth troll over here.
Well, David, why have we caught you laughing at some of the stuff that you say? It's obvious that it's an act, right?
Sure. Yeah, I've laughed about a lot of things.
He's
But
passionate.
we laugh at we're laughing because you can't prove that you live on a spinning ball. That's what we're laughing about.
Well, you just have the cotton in your ears, and you won't listen to anything anyone says because you're just trolling people. That's all that you care to do here.
No, water's always level, and you can't bust that fact for one.
Yeah, you can just keep repeating stuff. But we figured you out, David. Your act is done.
Always got to go into outer space. We always got to go into outer
We
space.
like to
And I'm
talk
just
about
people-
things other than like arguing and going on at each
This
other
is-
about
This is Flat Earth Debate 50, okay? And that's why you got to understand. I'm probably not going to come back on here after this one, but you got to understand that this is 50 right here, and
I
we've
sure
taken
hope
a bunch
so.
of rounds over here.
I sure hope that you're true to your word. That would really make this a lot better of an experience.
Sure, you could tell more lies over there. I know how the cow ate the cabbage over here, okay? And we got a lot of people on here that don't have anything better to do but talk about the ball being a spinning ball all day. You notice that there aren't flat earthers out here all day unless they're telling some crazy story on the internet 8 hours a day. But we have plenty of ballers that just stay on the internet all day long.
Have you met my buddy YouTube?
You're for one curved.
YouTube. YouTube is a flat earther on the internet 23 hours a day. Come on. David, wake up.
Okay, while these guys are in a bit of a wrangle-dangle about trolling on this show, which is always very entertaining, I'm going to let you guys in the audience know that there is about half an hour left on this stream, and there is actually, for this rare occasion, one gap left on the panel. So if you did want to join, be sure to mute the page you are currently watching and then click on the link in the info box below this video to join the show and express your views on the shape of the earth. If you wanted to support this channel, hit that super like, super share and super subscribe button, and and be sure to hit the bell notification icon to keep up to date with the Flat Earth Debate. With that, I'm going to transition back to the action and just say, if you haven't done so already, please share the show on social media. You may hear from me one more time just to thank you and round out the show.
The whole entire United States.
You dimwit,
How
the
about the whole
entirety
entire
of the
United States?
earth could be mapped out flat.
Is it warped? Is the
Distortion
map of the
free.
United States warped? The problem is we don't have a map of the world, man.
excuse
Why don't you
you
wake up over
guys
there?
always give is we don't
There's
have
no
an
map of the
accurate
world.
map.
This is debate 50, and there's still not a map
But
of the
here
world.
you are
Pull it out.
arguing
That
the
board-
accuracy
that man,
of a map.
That man
While
that
you're
had his
claiming you don't have
icon
accurate
as a
maps.
globe over there, he's showing that fake globe over there. That thing ain't right. Pull it out. Where's your fake map at?
I'm sorry for trying to oppose you, David. Keep it up. You're doing a great job destroying flat Earth. Just go ahead.
It's debate number 50 here, and I just had to come in here and take up for the flat earthers over here because you ballers seem to just muddy the waters all you can. It's like you get stick the engine in the mud on purpose just to muddy the waters up.
Hey, David, when are you going to do your fishing line test?
Yeah, you like that one, huh?
I do.
That
I
is
do
a
like
good
it.
one. That is a good
Yeah,
one.
I like it. I like it. When are you going to do it, David?
I say we do it with lasers and mirrors down a 150-mile beach down in Brazil. If I had the money, I'd go, but I don't have the money. I can't take
Do your
off.
fishing line test. Stretch out your fishing line a mile over a body of water.
I think if you took a laser and you went and you put a mirrors a mile apart, that laser would go for 150 miles straight.
No.
Yeah, it would.
No, I think you're deluded. No,
we
I
don't
think
need no shadows at all.
Hey, Jimmy, on that, I noticed you're zoomed into a very tiny portion of that image.
Well, this is the second one. This is not the one I just played with Charles. This is another one. This one don't have any shadows either.
But you see the little white box up there in the top left?
White box. Yes, that's my zoom in.
Okay, that's what. Yeah, that's you're zoomed in on a tiny portion of the overall image.
That's the zoom out.
Yeah, you're way far away. I'm wondering, how
Man, ain't no
reasonable
rockets
is it
landing
to
themselves,
expect
man. That's a
these?
crazy story.
Hey,
You
David.
have to be a kindergartner to believe
shut
something
the
like
hell
that, man.
up. Gibby, how reasonable is it to expect the shadows that you're looking for in this image? I'm wondering.
Well, this is the second one, and this is the first one I played before. This is a zoom in
Right.
now. Like
But
here
given
it is,
the-
not zoomed
Given
in.
the distance that the original photo is taken from,
Curve, do you believe that's real?
I got this off SpaceX's YouTube channel.
but given the distance that the original image is taken from, and then when you zoom in on that little part like that and blow it up, see you're
Do you think that's real, man? Do you think that's real?
This is digital zoom.
You think a rocket could land itself? You're so crazy, man.
Yeah,
I like when it lands itself backwards after a tilt.
So you have to be a baller to believe that kind of crap. See, folks, this is what ballers believe, that rockets can land themselves. Okay, because they saw it on a videotape. This is what we're arguing with right here.
I just want to know why rockets don't have shadows.
It don't land itself, man. That's phony as hell.
Well, Jimmy, I'm
Well,
wondering
clearly.
if I mean, in these conditions, if there's a shadow there that would be captured from that distance, and when you blow it up like this, that you're not going to get it. I'm not sure. I'm just asking a question because I'm not sure it's reasonable to expect the shadow that you're looking for.
Came in later. The shadow came in later after it did its ta-da, and the smoke's gone. Now it has a shadow.
You know what's interesting about that particular shot, Jibby, is that if you watch, there's a hatch that gets blown. There's like a hatch cover or something that gets blown as the rocket comes by, and it goes flying in a ballistic trajectory. Interesting that they added that piece of CGI, but not the shadow.
Oh my God, you should play some Grand Theft Auto. There's some awesome nonsensical CGI stuff getting blown around. Here it is right here, and I think, no, it's over here. No, there it is, and it's getting blown around. I have seen graphics rendering better than that. Like, ooh, that's not a difficult thing to add in there at all. Not at all.
So
it does add nice detail, though, to make it look like it's really there. And this thing doesn't have a shadow either, if you notice.
By the way,
as it blows around, there's no shadow to the piece of shrapnel going. No shadow for that either, because it's not really there.
They need to get a monkey to land it.
Yeah. It's a very bright day today.
This
no
is
shadows
exactly
for
what I
anything
mean
that isn't
about
there.
David just being a troll.
Why don't you apply for the job, David?
Yeah. I want to apply for SpaceX. I would have said you forgot the shadow, and then it would have been more believable.
I can't believe they don't have an Astro chimp on the top of that thing.
That's where I saw this first.
They got those
I would
Astro
love to
chimps
play
when
this game.
They had those Astro chimps when they told you the Earth was round, like in that picture that showed you.
They didn't even land it in Texas.
Remember Thunderbirds?
Can't be
Like the
real.
first
If it's
series
not
that did
Texas.
that, landing rockets.
So can we just give the? Oops.
You guys have some great evidence.
I encourage
Sorry
everybody
to
to
interrupt.
look
Can
for
we just give
themselves,
the?
go to the SpaceX YouTube channel, and specifically try to watch when the first stage is landing on either the land or the drone ship, and just watch. You'll see it cuts out 100% of the time, but the one that crashed or the two that crashed, clear, just fine. No transmission errors on those that crashed. No signal loss, but the ones that land successfully, there's always a signal loss. It's just funny, It's one of those things like,
Sure.
I look forward to when they don't have a signal loss and they actually say, oh, it's the satellite signal. It cuts out here and there, but they don't seem to have ground to ground transmission, I guess, when you're out on the barge like that or on land, because there's a signal cutout on land every time it just comes in the frame. It reminds me of the Pentagon 5 frames of awesomeness. Just
it turned to the virtual model, basically.
Sorry to do this. There's quite a lot of info getting thrown out, and obviously we've seen that video on repeat. I mean, can I do a little round robin and establish exactly who actually accepts that as reality and who doesn't?
What exactly, Nathan?
We've just watched a video that Jibby is claiming is CGI
CRS-10.
nonsense.
It's a CRS-10, it's called, yeah.
The CRS-10 landing, and it's claimed by Jibby that this is complete nonsense.
Oh, that's
so I just want to establish on the panel.
This is the CRS-10.
Just want to establish on the panel.
CRS-11, I believe. Yeah, CRS-11.
CRS-11. I just want to establish on the panel who thinks that's reality and who doesn't.
Fake.
Who said that? Sorry.
This David said fake.
Well, there are some clues you could look at. Hold on,
Like
let
no
me
shadows.
zoom in on.
Okay, so like here's
Can I
here's
please? There are
Sorry.
some very important clues that give an indication if this is real, and that is the landing zone. If it actually ignites and then leaves, then you should see the burning marks, and you don't see them here, unless they also trick that. So that's just common sense right there.
So you
Who
say-
knows?
so-
Maybe they
burn
actually
marks.
did it with
Sorry,
this
Arwin.
thing.
Thing.
It was a
Like
quick
burn marks.
round
Doesn't
robin
mean
for everyone on the
every
panel.
time you
Sorry,
see
Arwin.
something like
Sorry,
that,
Arwin.
it's real.
Arwin. I just wanted to get a quick establishment from everyone on the panel, just real or fake. So you're saying fake?
No, not necessarily.
I'm saying 1000% fake.
Okay, I'll just go along the panel.
1000%
So
some
curved,
kind of
what say you?
CGI insertion.
I'm just going to ask
Okay,
everyone,
so-
Jibby. So curved
Let
next.
me,
If I can just, sorry, epistemology. I will get to you. Just want to get a quick, just quickly, if you think it's fake or not. So
Well, hold
curved.
on. Hey, look at the waves behind there. They do actually move forward, so
Hold on, Arwin.
It might be
Arwin
partially
has stuff
cut.
to say.
and
Arwin, I know
everything,
you've
but-
got more to say, but I just want to establish from everyone on the panel where they stand, and there's like 9 people here.
Oh, okay, sorry. I'll shut up.
You go ahead, curved.
I don't see anything to warrant calling it fake. No.
Fair enough. Real from curved. David, I can guess already, but go ahead. Maybe not.
Fake? I don't know who you talk to.
Yeah, you, David. Fake. Good enough answer.
Oh, do you know how much power it would take to land a
Just
rocket
a simple.
like that?
Just a
Do you know how
fake
much
or
power
not.
it would take to land it and then
It's
hold
gonna,
it
it's
straight
gonna
up?
take forever,
David,
David.
I
I
mean,
really
you heard
wish I hadn't done this.
You have to be a 5-year-old to believe that.
Can
Fair
we get
enough. You
through
say
this,
fake.
please?
Epistemology, what say you?
Well, I've seen multiple Falcon 9 launches from Vandenberg from a great vantage point because I get to go on base to watch it. And I can tell you that one thing that you don't understand for the people that have never actually gone to see a Falcon 9 launch is that flame that's coming out of that thing is incredibly bright. It's like looking at an arc welding. When you're seeing it with your naked eye, it's like an arc welding. It looks like an arc welding.
Well, I'm glad you said that because it's not casting any light upon the ground until it gets right on top of it.
Watch it. You can see as it approaches, you can already see the light well before the flame
Yeah,
touches.
carrying enough fuel to
on
land,
dark
man, it has to
concrete.
take
Okay,
off.
you've
with that
already
fuel.
been-
Hold on. Can
Hold
someone
on,
let me
David.
finish talking? Can I please finish
Just let
my
him get to the end,
statement, please?
David. He's nearly done.
Can I please finish my statement? You can see as it approaches that there's already light being reflected in the dark concrete. Second of all, you can look by the shadows. You can see the shadows against the greenery here. That it's an overcast day. This is southern Florida, so it's an overcast day, which is common there because it's very cloudy there. It rains almost every single day, certain times of year. So
It's as
it's
tall as a
not
building.
unexpected that you have flat
Fascinating.
diffuse light, and at the same time you have the incredibly bright flame coming out the bottom of the rocket that's going to wash out any kind of very light shadow being created in the diffuse light until the rocket is completely off and that super bright arc welding light is off, that you would actually see the very diffuse shadow, which you do in the still shot.
Okay, if I can just
Not
get
to mention the fact that there are many people
no
that
disrespect to epistemology.
It's
Same thing as with everyone else. I just want to get through the rest of the panel. There's only 4 more people. So Jibby, we already know he thinks it's fake. Mr. Miss, what do you say?
Oh, I don't know.
Don't know. Good enough
I
answer.
mean, they have faked a lot of shit in the past, so you just don't know, do you?
Don't know. It's good enough answer. P Mars, what say you?
I think like the fire on the bottom should make it so there wouldn't be a shadow.
I want to see how it looks after the smoke has
Hey,
cleared.
there's different kinds of fuel, man.
One more
there's
person. I'm
liquid
really
fuel and
sorry,
there's
David.
gas fuel,
David, your
okay?
patience
There's
is a
2 different
virtue,
kinds
my
of fuel.
friend.
Rocket
David,
uses gas
David,
fuel.
David, for the love of God. Right, you've got no patience. Truth seeker. You're the last one.
Arwin. Here, Arwin. There it is. Post smoke.
No, I want to see it in one shot.
Okay. It just kind of switches over from smoke to no
yeah,
smoke.
that's.
Okay.
I want to see here clear up, and yeah, exactly what I thought. So that's not a very good sign.
They render
You can
smoke
just leave
and
that
water
running.
beautifully in video games now. Water and smoke are indistinguishable in video games. It's just rendered beautifully and so smoothly. It's hard to tell, except unless you're used to
Wouldn't they
seeing
have,
them all the time.
Why
Would
would
they-
they want a rocket to land? Why in the hell would you want a rocket to land? That don't make no sense either.
I think the footage has been reversed.
It's
Exactly.
It's
Are you
based on
kidding?
recycling the equipment, so you don't have to discard all the things and reproduce them. That's why they are trying this, according to their plans.
Jibby, I don't think you can really compare it to video game CGI because they would have way more advanced technology than a video game company.
You can only go so far on CGI. You
Jimmy,
really
have
can,
you
unless
seen-
you're
have
getting
you-
to pretty much the real thing.
The only
Jimmy,
way you
have
could do that was with a turbine fan. You couldn't do that with gas like that. You couldn't use a gas.
Jibby, have you
Why
seen
not?
Red's rhetoric video of the landing? Because you can watch it
I
all
did,
the way
and
to
it was
touchdown.
from far away, and it looked very
But
cartoony
you clearly
to
see
me.
the rocket come in, approach, and you can see it come to a landing straight up.
It looked very cartoony to me, and I know that they have outdoor
So you're saying
holograms.
that
You
Red-
see them
that
in
Red's faked
Disneyland.
it?
You see them in Disneyland, outdoor holograms all the time, and
Can we
that's
see that?
Disney, and that's civilian.
Do you have that
Like,
epistemology?
Can you
Can we
imagine
see that?
It is
the
kind
version?
of blurry
Okay,
just around the rocket.
so would you be
Why?
willing to sign a contract where if I funded you to go down and see this landing, you would have to pay me for the cost to do so?
I would need to get close, like very close to it. No,
See?
otherwise, it could be an
You can
outdoor
see- if
hologram
you can
for all
see
I
it from
know.
the perspective, if you could see it from the
Augmented
perspective,
hologram.
if
It
you can see
seems
it
to
from the
blur
perspective of
around it.
Red's rhetoric, where you can see it approach from the sky, you can see it come in, you can see it hover down and land, and you can see it standing
Wow.
straight up after it touches to the ground. That
They
is not
could
enough
never
evidence
put-
for you.
They could
That
That
never
isn't.
put
There's
a
no.
portable
That's not
drone.
landing. That's taking off.
This is landing. This isn't taking.
No,
off.
it can't
This is
be landing because the fuel's coming out the bottom of it, so
Oh
it would
my
push
God.
up. It'd go up.
Oh my.
It's been reversed.
No, that's counter thrust.
Epistemology. Somebody's got to answer. It can't be me because I'm about to lose it.
No, I mean it's total nonsense. Obviously, yeah.
Do
The
you
thrust
have
is
that
not
footage?
the thrust that it's producing is not enough thrust to maintain the altitudes or the rocket's altitude, which is
How much does that weigh? 15 pounds or what? You think that's a 3,000 or 4,000 pound rocket? They're just landing like that? 10,000 pound? What do you think?
Well, I'm
I would
thinking
think
now
that the
that
exhaust flame would be much larger for that
yeah,
size.
well, there would be much more thrust that would hit the ground much earlier. That is
Hey.
kind of suspicious.
Jibby,
It's
do you
fake,
have the
man.
ability to play that backwards?
Yeah, you got to land a 20,000 pound thing like
Can
that.
we watch it? Can we watch it take off after?
Yeah,
you know,
that's
it
Let me see if I
reversed.
can do
That's
that.
not. It's not
Let me
landing.
see.
That.
and watch all the smoke go back into the rocket as it takes off?
I bet that rocket flies level when it's headed out, huh?
Epistemology said he had some of the footage of a further vantage point. Is that correct, Epistemology?
yeah. I have one of the CRS-10, which is from a much further vantage point, where you can see that it's a cloudy day with diffused light.
Here's the CRS-10 right here.
Oh,
the
perfect.
same footage that Jimmy has. You can clearly see that
No,
by the
there's
clouds
I
and the
used two different
shadows
ones.
that this
is
is
two different
completely
ones.
diffused light.
And here it is, crystal clear focus, far away, as everything else at that distance is slightly blurry, which is another sign of CGI, because CGI isn't focused unless
there
they
is
dull it.
blur around it.
What is slightly blurry that's in that photo?
Everything around the rocket.
Everything
part
around
itself.
it. Everything around it.
And in a
is
constant,
focused
it's not-
as it stays in
it's not
focus.
gradual.
One at a time. One at a time.
These are the
please.
same guys that sold you a picture of the ball from space too.
I don't see
now
this
I can
effect
zoom in
either.
on this
You said it was like
closer.
a
You
welding
get a better
torch
look.
epistemology, and I don't see any of the land changing in brightness at all.
Right.
You said it was
There's
like,
like a
arc welding.
blurry rectangle.
It would have to. It would have to move up and down. If it was running on gas like that, the
You-
thing would
if
have
you
to move
pause
up
it,
and down
when
and
you pause it
position
when you have
itself.
about one
It
or
wouldn't
two
just go
rockets.
straight down, man. Are y'all are crazy.
Pause it right there, Jimmy. You can already see the lighting effect on the pad there.
And that
Yeah,
can't
but
be
you don't
done
see
with
the
software.
thrust.
You can already
That
see
can't
the
be done
pad
with
there.
software?
Keep going. Keep going.
You don't see enough thrust.
See
You
how
don't see
you
it
can
there,
already
but
see
you know-
you can see the light, the luminosity
should be
change here on the
lit
pad.
up
And
like-
keep
it
in mind,
should be
this is
lit
the
up-
middle of the day. This is
It should be
daytime.
lit up like the sun, that close. The
It would
ground
have
should
to
be lit
push
up like the
itself
sun.
back up to slow the speed. You'd have to have a up position on it. It would have to thrust itself up to slow down. It wouldn't just come straight down.
Can we just clarify something though? You've seen this, haven't you, epistemology from this
I've
vantage
never
point?
seen a landing. No, I've never seen. They don't land. They don't
have
land
that part
like
blocked.
a Vandenberg.
Yeah. to the public.
They land on a barge. I've seen lots of launches. I've never seen a landing.
Have you met somebody that knows somebody that might have met somebody that saw it land?
Rhetoric has seen it land. It's something that most of the people on this panel have talked. Someone that most of the people on this panel have talked.
Jibby, could you play this exactly in reverse? Just
I
to
don't
show
have that
how would
ability
look?
on VLC Player to play it in reverse. I would have to put
Really?
it in one of my programs, play it backwards, and then render it that way.
Okay, would be nice to see.
But this is right off the SpaceX YouTube channel, and this is the CRS 10 and CRS 11. They're only 30-second videos, and they're very quick to download. Download them yourself, play them in your own player, download the high quality, zoom in like I am, and judge for yourself.
It never moves up. You never see it push itself up to slow itself down. It'd have to push itself up, man. You couldn't sit there and just come straight down without pushing
Dave.
yourself up.
Yeah, that boy, get him, Dave.
Well, you don't believe that? You
Crush
think it
that
just comes
flat
straight
earth.
down? It wouldn't sway or wiggle a little bit, huh?
Crush that flat earth. Keep going, Dave.
Not unless they use an exact pre-planned system.
I'd love to see you be able to play it backwards so we can watch all the smoke go up into the rocket.
I don't think
as it
backwards
takes off.
has anything to do with it. It's just CGI. It's not like a real rocket that they.
I'm
just put
addressing the
backwards.
issue of the accusation that they're just playing the film backwards.
I don't believe that. I think it's just CGI overlay.
But the claim was made, Jimmy. You understand that, right? You do understand the claim was made.
They got a boom out there. They're
I'm
lowering
addressing
it
that
down.
claim.
You can't see it.
I'm addressing.
Then it wouldn't be CGI. Then it'd be real. It would just be a practical effect.
Yeah, practical effect. That's probably what it is.
Erwin, I forget what you said. Did you think it was real?
I'm not
Arwen?
sure. It's
I'm
not
sure.
just a basic played in reverse thing. If there's a reversal effect, then it's very elaborately tampered with. It's a detailed CGI project.
Just
But
think
I
about
want
what
to
it,
just see how it plays in reverse and then make up my mind if it actually is in reverse. Because
just think
I would
about what
show-
it takes to stop your car when you're pushing on the brakes going 100 miles an hour. Can you imagine what it would take to stop that thing from dropping?
Look at the objects around here. You gotta appreciate the size of this thing. This thing is monstrous and
Even more
not
crazy.
a lick of a shadow anywhere. It's literally the Empire State Building is like landing, and there's no shadow or no anything. It's as if this is an inlay, a CGI inlay with smoke rendering and all of it, laid on top of real live footage in the background. Here's birds flying, which could be added in, but it looks real enough. That's hard to tell, but it's CGI overlay. It just looks extremely like it sticks out. Hard in focus that you
There's
can
a
tell
block
it's not
of
real
blur
photography.
around it. An exact rectangle of blur that follows it exactly around it. Do you see that? Like every part of the footage, there's like a rectangle, like the bands are exactly as wide as the tube itself around it, and you just see everything in that block blur.
How big is it?
Yeah,
How big
right.
is it?
Because there's tremendous heat coming off of that thing, so that's why. And part of it is also the compression algorithm. Yeah,
The
some of
entire
it
thing?
is
So the heat goes all the way up that tube. Wouldn't that
because
be
there's tons of
extremely
heat.
dangerous?
In fact, you can see after it lands how it gets even more distorted because there's more heat that's rising up. That's the residual.
You can create that effect with a hair dryer, Arwen.
If you can see this effect over. Like, look next time. Look through the exhaust of a diesel truck or a bus.
Yeah, I know.
You ever
I'm
get
just
one of those?
telling you what I'm observing. That's all.
You ever get one of those toys for? You ever get one of those toys?
It's a very compressed image here.
You ever get
a
one of
clue,
those toys
David?
when you're a kid and you pump it up with the water and it was a rocket and it was a water rocket? You remember those? And you pump it up.
Yeah,
and it go like 40 or 50 feet up in the air. Okay, how are you going to take that same pressure? Rockets take off with pressure. Okay, it doesn't keep pressure in there enough to land it. I don't. You act like it's.
No,
gonna
it's
just-
thrust. It's burning up of fuel. That kind of situation.
It's burning.
The engine is throttleable, right? You understand that, right, David?
It's done with thrust,
It's a liquid-
man. It's
it's a
not
liquid
done.
fueled
It's not
rocket
done.
engine.
With
Chemical
wind.
thrust. It's
It's done with thrust. It's not done with wind. It's not like a turbine engine off an airplane, man.
It's not a CO2
no, it's
cartridge.
vertical thrust.
It's
a
basically that's what it
fuel.
is a CO2 cartridge with liquid fuel in there or gas fuel.
It's
It's
burned.
not even got liquid fuel.
It's
It
burned.
burns, yeah.
The actual burning that's causing the thrust, not the physical pressure of the gas itself. being released.
Exactly. That's what I'm trying to explain to you. They have to release enough gas to get the thrust. Okay, so it's almost an even amount of thrust versus how much gas you
So
got.
there's no regulation within that system.
It's a regulation. It's a big valve on there that when they hit it, it opens that valve and it pushes it off. They can't just sit
I
there.
think it's a little bit more complicated than that.
No,
There's a control system, a digital control system
man,
for
there is no
the
control
gas release.
system on a rocket, man. They just open a valve on it and let it ignite the son of a gun.
Yeah, you're trying to make it out like it's a compressor tank, David. Give us a break, man.
I'm saying there's no parts in there other than the one little battery to light the fuse.
No, come on, that's
total nonsense, dude.
There is no
The
engines.
liquid rocket fuel engine,
It has no engines. So how can it land itself?
that's total nonsense.
How does it doesn't have an engine?
Go Google.
It doesn't have an engine, man. It's using thrust from the fuel.
Why don't you
My
put some
dinner's getting
fuel
cold,
in a
guys.
can?
I just wanted to say goodbye and thanks for having me here. I gotta go though, but thanks for having me, and I'll be back soon. You guys have
It's a pleasure having you, Jibby. Thank you very much for being here. Good to see you.
I mean, it's common sense.
I'm just going to let the audience know there's about 5 minutes left on this broadcast, so if you did want to join to do some last-minute trolling, now is your opportunity. Please share the show if you've not done so already, and hit that subscribe button if you're not subscribed.
Number 50, folks.
All right,
Earth's
okay.
flat.
David, fill up a container with some fuel and light it, and show me how
Put
this
it under
works.
pressure. It's all under pressure, man.
Show me how it works.
It's all pressure. You can't do it the way
Come on,
that you're
David.
talking about.
Test your theory.
It doesn't work,
Test your
man.
theory, David.
What does it matter if it's under pressure, David? Come on.
It makes a difference because you have to hold a certain amount of pressure to land the son of a gun. You would have to bob up and
David.
down to get it to land.
There's
Okay,
pressure
it would go up and
regulation
down.
systems,
You'd have to go down a little bit and come up a little bit. Go down a little bit and come up a little
Arwen.
bit.
No, you don't.
Arwen. The
couldn't
thing
just
is,
come-
David made a ridiculous statement, and he can't back down from it. That's
On
all
top
I'm
of the
saying.
fact that, David, you can go and watch this thing come in and land yourself. Okay, all you have to do is go be in Florida at the time that they do
But
this.
yeah, sure. Yeah, we go down there and see that Southern Cross Star too down there, and it's going the opposite direction. We've heard all about that too. Folks, we got a bunch of people on here telling these stories that aren't true. So the Earth's flat, and I'm just glad to be out here.
David, we know that you're a troll and you don't actually believe anything you say.
Yeah, I'm a
David. So
flat
I
earth
think from this
troll,
point on,
I'm a flat earth troll, and this is the
I would suggest that the Globers don't even.
You're in a
respond to
flat
David.
Earth debate, sir. That's what it is, and you have no proof we live on a spinning ball.
Well,
Other
you're
than
not
rhetoric.
here to
You-
debate. All
You're
you're here is to
some
yell at his
instigator.
assertions.
You,
All
yeah,
you
you
do is
don't
yell at
debate.
assertions.
You have horses, David.
You and Curve both. You sit around talking all this stuff, but you have no proof, and that's the main
Do
thing
you
we're
have
here.
horses,
In debate
David?
50, where we still have no proof from the ballers that we live on a spinning ball.
Have you been thrown from a horse or kicked in the head by a
No,
horse?
you don't worry about that. You just need to come up with your proof we live on a spinning ball over here.
Oh, come on. What kind of cowboy ain't got no horse now?
Man, I got a good dog. I don't have to worry about that.
Uh-huh. Oh, Bobo kicked you in the head.
It's hard to carry a horse in a diesel truck, man.
Oh, Bobo kicked you in the head.
A horse without a farm is not that fun.
I got a farm, but I didn't say I don't have any horses. But
Oh.
I
Put
just
'em
want to
on
say,
hold.
hey Nathan, I just want to say thank you for 50 good debates here. And somebody, I just felt like I had to step in here and at least throw somewhat of my point of view at it anyway.
It's always appreciated.
Pleasure.
But, it's a good thing. I'm just glad everybody is debating it, and it's gonna come out real soon.
Yeah.
You bet that.
So
I did a show on the occult on my channel at PMARS. If anyone's interested in that, I showed how Trump is connected to Scientology, for example.
Did you link to Nathan's super chat in your hangout? You know, them's the rules, P. Don't come on here and
Yeah,
talk about
Scientology
your
is pretty
show.
powerful.
You didn't like.
Hey, any of you flat earthers getting a debate with these globers, ask them where their map's at. That's the main. Just say, where's your map at of the world? And they won't have one. So
where's
you
your
win it
map?
right off the bat.
Where's your map?
I have one map, and that's of the United
Map of the
States, and
world.
I know it's correct. Okay, I need the other
Map of the
seven.
world,
I need
David.
the other 6 continents.
Then make one.
Maps of the other 6 continents, and
Get
we'll know
on
what
it.
the real world looks like.
Get on it. Antonio can map the world from the comfort of his dining room table. What's your excuse?
We needed 1 to 500, 1 inch for 500 miles. We need to see it in person. It fit in a 12 by 12 on a 12 by 12 wall probably.
There you go. Well, get on it.
Nathan, appreciate you. Gonna come in and say something on debate 50 here. He's just gonna let us go, I guess. Go ahead. You there, Nathan?
Yeah, I thought I said thanks. It's a pleasure having you, as always.
Yes, sir. I just want to, like I said, this is the Flat Earth debate. Have you decided how many you're going to do?
I enjoy doing these. I might do them indefinitely.
Oh no, man! Oh,
maybe.
I guess I'm gonna have to be nicer then. I'm sorry I sound kind of, but that makes me mad because we know they're all in here lying about this stuff, and sometimes you just got to stand up for yourself when you're talking to these ballers, because a lot of them work for the government anyway, and there a lot of people need to know that. But
maybe there's some way. Maybe there's some way to do David's fishing string test over a long pool or a big body of water.
Yeah, I like that.
Live on the Hangout.
We need to get a fishing line in the back of a boat. We're gonna carry it, make it tight for 100 miles. Don't be careful out there.
Tight for 100 miles.
You think any flat earthers work for the government, David? Like maybe Mark Sargent?
Well, there's a few, but I'm not. They're mainly the ones that do the like the simulation theory and stuff like that. Those are the flat earthers doing the muddy in the waters. If they come up with this stuff like that, you live in a simulation or you're in a diamond map or any of this stuff, they have them on both sides, and you got to go with the information. The one thing that they don't have is a map. Okay, we do not have a map of the world, and that's the main thing.
Correct.
Because it won't fit. We don't have a map.
Got time for a quick hello to Lewis Hackett. So hello, Lewis. It's going to be a hi and goodbye though.
Good point, David. Lewis. You do not have a map. Excellent. Get him, Lewis. How much time left?
Lewis, come in here. Go ahead, Lewis.
60 seconds. 60 seconds.
We do have a map.
Like old video, man.
We got that invisible map over here. Let's see it, Lewis. Pull it out. You got about a minute left to show it. You better hurry.
Have you ever looked at an atlas?
I want to see that atlas map. It's right behind you in A. Pull it out. Let's look at it.
Have you ever seen an atlas, David?
I know how an atlas. I've read them.
What are you saying when you say we don't have a map? Like we have thousands of maps.
You have lots of projections.
He argues both sides.
We don't have a map of the 7 continents like we have of the United States. Okay.
Speaking of working for the government, and then Lewis shows up.
Arwen, what's a projection?
A projected map, basically.
Projected
a representation. Changed aspects, dimensional aspects to fit a piece of paper, a flat piece of paper.
Change from what?
From whatever shape it is suggested to be.
The globe.
Yeah, that's your suggestion.
Land masses. We don't even care about the water here, okay? The water is not important. We want to see the land masses to scale. One continent at a time. All 7 continents to scale at 1 to 500 miles. That's what we want to see, okay?
So go get that. If that's what you want to see, go get it.
And with that, I'm going to say a huge, enormous, massive thank you to the audience for watching and sharing and liking, and also a massive thank you to the panel for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.